Salutare și bine te-am regăsit din taxiul viitorului. Știu că ți-am arătat de prea multe ori mașini zburătoare, dar chestia asta chiar o să zboare. Mai durează vreo 3-4 ani până atunci, însă acest supernal o să se ridice de la sol și o să te ducă oriunde duc bateriile. Pentru că ce vezi în spatele meu este un fel de aerotaxi, trebuie să învățăm cuvinte noi, este un eVTOL. O să-ți spun mai multe un pic mai încolo despre ce înseamnă toată chestia asta, dar gândește-te așa, că o să poți comanda chestia asta într-un loc care să ducă în alt loc și de acolo să iei un alt mijloc de transport. Și până să-ți intru în detalii, am un interviu genial cu singurul pilot de test care poate zbura așa ceva un pic mai încolo. Hai să-ți dau o tură de jur împrejur și să înțelegi cam cum funcționează. Cred că recunoști deja silueta unui elicopter și ce vezi aici în spatele meu este în esență un fel de dronă combinată cu elicopter, dar și cu aparat de zbor, cu aeronavă. De ce? Pentru că poate primi la bord în momentul acesta 4 pasageri plus un pilot, iar un loc din față a fost sacrificat pentru bagaje. Este destul de greu să obții foarte mult spațiu de depozitare când trebuie să pui baterii la bord. Ce vezi aici este un aparat de zbor cu 8 rotoare și câte 2 motoare pe fiecare rotor. Sunt 16 motoare electrice care pot oricând să se întrerupă câte unul, fără ca pilotul sau pasagerii să aibă orice fel de problemă acolo. Ba chiar și în astfel de situații o să ajungă destul de repede la sol. Stresul meu nu este în legătură cu un risc de accident, mai ales când ai motoare atât de performante, pentru că acest supernal e făcut de cei de la Hyundai Motor. Sunt o companie foarte mare care deține mai multe companii auto. Nu confunda neapărat cu brandul de automobile. Arată într-adevăr spectaculos, iar acest prototip este unul, vă spuneam, care poate să zboare. Dar cum o să zboare propriu-zis? Păi se ridică toate rotoarele astea în sus, se ridică foarte repede la sol și apoi pleacă către destinație și o să zboare cu o viteză de până la aproape 200 de km la oră. O să zboare maxim jumătate de oră, pentru că scopul unei astfel de aparat de zbor este să te ducă, vă spuneam, destul de repede între două puncte, de la punctul A la punctul B. Poate să fie de la un aeroport, pe o clădire de birouri sau într-o parcare sau undeva, nu știu, la un teren unde ai tu o activitate în câmp sau la ferma ta de cine știe ce crește acolo. Însă este un obiect interesant, este un obiect spectaculos și este plin de tehnologie. La capitolul energie, spre exemplu, în loc să folosească combustibil, folosește electricitate. Dezavantajul însă, de obicei, la toate conceptele și prototipurile pe care le-am văzut până acum este că motoarele acestea erau destul de zgomotoase. Ei bine, în configurația asta are 8 motoare și fiecare pală este diferită și modificată astfel încât să aibă minimum de zgomot posibil. Inclusiv colțurile sunt îndoite, acele mini-wingleturi, cum se numesc ele în aviație, care sunt făcute să taie curenții de aer, astfel încât să nu creeze prea multe turbulențe. Fiecare pală are altă frecvență pentru ca acest aparat de zbor, când o să treacă pe deasupra casei tale sau unui bloc sau un spital sau o grădiniță sau o școală din oraș, să nu facă o gălăgie mai mare, să zicem, decât o mașină de spălat. Asta este nivelul de zgomot pe care și l-au propus și eu cred că o să-l atingă destul de ușor, pentru că știm deja de la drone că la început erau foarte zgomotoase, după care, recunoașteți forma asta de la elici, au început să devină din ce în ce mai rapide, din ce în ce mai silențioase, dar au și autonomie din ce în ce mai mare, pentru că jumătate de oră în aer nu ar să fie o problemă pentru acest aparat de zbor, plus că el are și rezerve suplimentare. Hai să vorbim un pic despre unde ține energia. Păi, în aripile astea o să aibă loc și este bine că este așa, pentru că îl va echilibra și mai bine. Are baterii de generație actuală, însă poate primi baterii îmbunătățite pe măsură ce o să vină cele semi-solid state și solid state. O să mai vorbim despre ele. Important este să știi că aceste aparate de zbor beneficiază maximum posibil de pe urma inovației din domeniul bateriilor pentru telefoanele mobile. Datorită lor avem mașini electrice, dar și astfel de obiecte care pot decola. Legătura cu telefoanele mobile este inclusiv acolo la pilot. Pilotul are la dispoziție 2 tablete mari, 2 joystick-uri, însă aparatul acesta de zbor, așa cum îl vezi, poate să zboare singur. Deocamdată nu are voie și producătorul a înțeles că dacă vrea să aibă succes, trebuie să convingă oamenii să urce la bord și autoritățile cu un pilot care să fie acolo just in case. Știți cum? E ca la Tesla, care tot promite că până la sfârșitul anului o să vedem vehicule autonome, așa promit și cei de la Supernal că poate să zboare autonom. În realitate, tehnologia există și nu e chiar atât de greu. Au prezentat aici un ecosistem complet, aparatul de zbor cu aplicație, cu centrul de control de acolo. Uite ce bine arată pe ecranele alea, poți să vezi toate traseele, harta meteo, zonele unde poate să zboare autonomie și integrarea cu aplicațiile de ride sharing. Că până la urmă, un astfel de obiect de zbor nu este singurul pe care trebuie să-l folosești și nu cred că îți trebuie unul pentru tine personal. Nu cred că ne trebuie mașini zburătoare pentru fiecare dintre noi. Dacă vrem să ieșim din trafic, să ne ridicăm deasupra sau putem să mergem de desubt. Putem folosi tuneluri sau obiecte zburătoare, pasaje și tuneluri și alte asemenea. Important este să folosim la maximum orice mijloc de transport cu minimum de emisii și de zgomot. What better way to learn more about the Supernal but from a pilot?
That's right.
The only guy that can actually fly the thing.
Yes.
RJ, thank you for taking the time.
Yeah, thank you, George.
How can you actually fly a thing like this? And why is there only one of you or two test pilots that can do it?
Well, right now at Supernal, I'm the chief test pilot, and I have the good fortune of having flown prototypes for other companies before. So that's kind of the primary reason why I'm one of one really, and
one of one
here at Supernal.
Can you imagine one of one who actually flown something like this?
Yeah. But there's two pilots in the world that have actually taken off vertically, transitioned onto the wing of an eVTOL, and then landed to a precision hover, and I'm just lucky enough to be one of them.
Okay, so that means you signed all the waivers.
That's right. I signed all the waivers, and I signed the insurance form as well. So my wife.
So what's the insurance on your head?
Good question. Yeah.
The wife knows.
Yeah, she knows, and yeah.
Okay, so that's a test pilot that can actually take off, but also fly the thing. And we're going to explain together why do you actually need not only to take off, but also fly the thing up to 193 kilometers per hour from what we've been talking.
Yeah, 193 kilometers per hour, 120 miles per hour is approximately is the cruising. So once you lift off from a hover, then we will cruise at about 1,500 feet above the ground, which is maybe 500 meters ish above the ground.
Above any buildings?
Yeah, above buildings and away from the terrain and stuff. So nominally, it's a 1,500 feet cruise altitude.
Okay.
Right?
But before we get there, before we take off,
sure.
Show me the bird, show me the craft, and explain it to me how it works.
Yeah, okay. So this is the Supernal, what we call SA2 concept vehicle. We just unveiled it here at CES day before. Was yesterday. Yeah, just yesterday. So this is an 8-rotor configuration. So you can see you've got these 8 rotors, 4 in front and then 4 in the rear. These 4 in the rear also rotate, so they'll rotate down.
So they all rotate?
They all rotate or tilt.
90 degrees.
That's right, yeah. And the ones in the rear are in what we call our cruise configuration. So that's when we're on the wing, they'll be in that configuration. But it's 8 rotors. And then you can see the blades. It's 4-bladed design here for the propellers. Okay. And the propellers also change pitch, right? So you can change the thrust vector by just changing the pitch because they all rotate at a certain RPM.
A certain RPM, but is my guess correct that they are also different from one another to have different frequencies for noise considerations and also the tips?
Yeah,
have winglets.
That's a really good observation. So you can see the tip is swept, right? And that's for noise, right? And in fact, the shape of the blade itself is all intended to minimize what we call our acoustic signature or the noise, right?
So how noisy is it going to be in an urban environment? Am I going to hear it?
In hover, we think 65 decibels. And once you're on the wing, flying like an airplane, 45 decibels. Which is as quiet as what they say a modern dishwasher.
Okay. So that wouldn't bother me if it flew over my house or
That's
my,
right.
my,
Yeah.
my flat. Okay.
Yeah. So the whole point of it is it's clean, quiet, and safe, right? So if you're going to bring this into the urban environment, those are the things that matter, right? Clean, quiet, and safe.
How do you make sure it's safe? So let's get back to
Yeah.
safety. Everybody wants to know. You're the chief test pilot,
Yeah.
101. You signed the waiver, but what about the people you're going to get on board? So
Sure.
you told me there's 8 rotors, but actually 2 motors on each one?
Yeah, 2 motors on each rotor, right? So any one of those motors can fail and we don't care. It's okay. It'll fly just fine and fly safely to the landing.
Okay.
You can see that it's redundant. So if any one component fails, it's okay because we have the rest of the components will make up for it, right? And even the battery system is set up to where it's segregated into systems. So if one battery fails, it's okay. We can isolate that and use the rest of the batteries.
What
to
are the
do
batteries?
The batteries will be likely a portion of them will be in the boom, a portion of them
Okay.
will be in the wing.
Also in the wing?
And yeah, potentially in the wing, and then potentially, I don't know exactly on this configuration if we actually need to put any in the fuselage or not.
Because I see there's 4 seats, there's the pilot seat, some luggage
Yeah.
storage space.
That's right.
There's some-
and then this is all avionics, and it could be some batteries in there as well.
Okay.
So I don't know exactly the configuration of where the batteries will be, but we've got lots of options of where to put it, right?
Okay.
So
Okay. Because in aviation, you actually have the fuel inside the wings.
usually you have fuel inside the wings, and then sometimes if you put weight out here, and you then it's actually beneficial for the wing structure, right? And so the wing is lifting up weight from both sides of the wing,
Okay.
right? It's not all isolated there.
Exactly. Because we've been showing people for the past few years all kind of flying machines, aircraft.
Yeah.
Cars turning into flying aircraft.
Right.
This is different.
That's
how
right.
How do you actually categorize this? Which category falls?
Think of this like an air taxi, right? So it's an
Okay.
electric air taxi. It can take off and land vertically, so it's an eVTOL, electric vertical
eVTOL.
takeoff. Yeah, electric vertical takeoff and land.
Okay.
Okay, so it's an eVTOL air taxi. The intent, and you can see in here, there's 4 passengers and 1 pilot, right? And then there's room for baggage.
So the purpose is taking people from one place to the other.
That's right.
In an urban setting.
Yeah, urban setting, a vertiport like this, maybe you get here with some sort of a taxi or something, a conventional taxi on the ground, and then you show up here, your flight, it's all part of one app, so you get the taxi gets you here just in time, your airplane's ready, you jump in here, you get to where you're going, and then you do that last mile with another mode of transportation. Maybe it's a taxi, maybe it's a bike, or maybe you can walk, depending on where you're going.
Can I imagine a scenario? I'm flying into the airport here. From the airport, you take me with the
For
supernal
sure.
here.
Yeah.
I get off and I cross the street to the Vegas Loop, the boarding tunnel.
100%.
Get a car inside of a tunnel. Get to my meeting in Central Hall.
Yes, that's exactly the model.
So that would be 10 minutes from the airport to my meeting.
That's right, yeah. And conceivably, you could get right off your airplane, jump right in here, land right at CES, do your business, right? And so in a lot of ways, this is a time machine, right? It saves you time, right? And that's really, our time is extremely valuable to us as humans, right?
And it's not only about time, it's also about using the city better.
That's right.
Because you're going into 3D instead of
That's right, yeah. So we're alleviating some congestion that would otherwise be there, and we're doing it in a clean way, environmentally responsible way, and in a safe way, right?
Thank you for showing me all that, but I'd be curious to learn from you as a pilot how it actually is to fly one of these things.
Yeah, so the experience is just incredible. When you have a really mature aircraft like ours, it's very graceful, it handles very well. The stability and control is it's digital fly-by-wire, so you can make it feel like a really graceful, nice aircraft just by tuning it in the computer, and then we get it to fly really nice before we ever end up in the air. And then once you get on the wing and you are flying, it is so quiet and so responsive. You know,
A kid could do it.
yeah, and you know how it is to drive these electric aircraft or electric cars, excuse me. Like if you've driven a Tesla and you can accelerate like right now, that's the same here. You have immediate acceleration capability, so it's very responsive, but also very quiet. So that's one of the things that maybe you can draw a parallel from electric cars. Is it's very responsive, but very quiet, right?
From my understanding, the best way to do it is to just take off and go as quickly as possible to cruising speed.
Yeah.
Tell me more about it.
Yeah, so I'll tell you why. One of the reasons is when you hover, it takes a lot of power to hover.
These things go vertically, and all 8 rotors pull the craft up.
That's right, yeah. So the aircraft is lifting you up vertically, and it takes a lot of power to hover and to climb vertically, right? And so you really don't want to spend a lot of time doing a hover because you're depleting your batteries of energy, and that energy is range. So you want to use that to go further. So the idea is if you want to go maximum distance, you lift up and get on the wing as quickly as possible and get to where you're flying on the wing and not on the rotors, and that is much more efficient.
How much more efficient is that? Because from my understanding, the most energy is going to be taking off.
Yeah.
And for how long can you simply hover?
Yeah. So usually these designs, you don't hover for very long at all, right? So minimum, maybe no hover. The best is no hover, right? Where you lift off and you just get going, right? And then for the wing, it's roughly, maybe it depends a lot on the design. So this one, I don't know for sure, but you could expect that it would be 1/3 of the power to fly on the wing compared to hover, right?
So this is why a drone or a basic helicopter needs much more fuel than a fixed wing.
Yeah, so I don't know about the fuel per se compared to helicopter, because helicopters, number one, they have a really large rotor disc, and many times they're not going as far as an airplane would go anyway, right?
Yeah.
But you would take as much fuel as your system allows, and then usually you'll have a radius that you can fly, and you know, okay, this helicopter can do 150 nautical miles, maybe another one can do 300 nautical miles, depending on how much fuel you can carry. This one, the distances right now for electric are somewhere in the 40 nautical mile range. You can reasonably expect.
In kilometers, it would be around
maybe 80 kilometers.
80 kilometers?
80 kilometers, yeah. 80,
in
maybe
a straight line.
85, something, yeah. A little bit more, maybe 90 kilometers, yeah. But it's 2.2 kilometers per nautical mile.
Okay,
yeah,
okay. With a speed of up to 193 kilometers per hour.
That's right, yeah.
Okay, so basically half an hour of flight time?
Ish, yeah.
Ish.
Yeah.
Okay.
Yeah.
So that means you have a decent battery density, energy density in your batteries. But from what I'm hearing, right across the street, I've seen a car with a semi-solid state battery.
Yeah, that's the thing. So here's the other beautiful part about Supernal's design is modularity, right? So our batteries are modules. When we can take out our lithium-based batteries, and when there's a new chemistry that's better, we can take out the lithium-based and go to a newer technology when it's ready.
So whenever the energy density doubles, you can double the flight time with the same mass.
Yeah, I don't know if it works out to be exactly double, but it's something like that. Yeah, or you have additional utility, right? So now you can say, hey, I'll do a job, maybe I will hover more, or I can do something that requires more hover because I have the energy density to do that.
Yeah, so I can have more space for luggage or stuff like that?
That's right, yeah. You may be able to carry extra weight or maybe go further, or maybe hover for additional time if that's part of the mission.
RJ, could I get you into the pilot seat?
I think you can.
Because I've seen there's a spot, there's an opening over there.
Yeah, okay.
Let's go. That's history right there.
Yeah. So you can see the flight controls. We've got this 2-stick configuration. And then you've got the displays. These are sort of modern displays where you would have a primary, what we call a primary flight display, and then maybe a multifunction display, and then a few controls to turn on the low volts and to turn on the various systems of the aircraft, and maybe a parking brake as well.
But that's pretty basic for an aircraft.
Very basic. And so the beauty of this is everything is controlled by the computers. So really all you need to do is turn it on, and then you can do everything with touch screen and it's got a lot of systems to automatically check and update the pilot. So you will see everything on the displays.
Whenever you're actually gonna get to fly one of these, most of the time you would be working how long? 5% of the time, or?
Maybe. So I'm sorry. So you think
actual pilot work is going to be how much of the flight?
Oh yeah, it would be very little actually. So you will get in and turn it on, check it, and then you are just babysitting the aircraft in case something happens, and then you can communicate. But in most cases, the aircraft will handle almost everything.
Because is it my guess that this thing is supposed to fly itself at one point?
Yeah, oh, for sure. It will have, there will be certain features, even with our piloted vehicle, that will have autopilot-like capabilities, so you can tell it to hold the altitude or the heading or whatever, and then there's nothing to do but just wait and communicate, So one of the things that the pilot needs to do often is to communicate with the air traffic control and with the base to make sure that they're ready for landing. And then you're also there for contingency, right? So if something does go wrong, that's where the pilot really buys their way onto.
And then you take over the joysticks.
That's right. Yeah. And for takeoff and landing, you will almost always do it manually until maybe there will be a time when you can do it automatically.
Okay.
But initially we'll do it manually, and then once you get going, just give the autopilot a heading altitude and speed.
And before 2030, we might get this one on a ride-sharing app.
Yeah, for sure. I think that's the goal, is to see this. 2028 is the goal for the market, and sometimes it takes a little while to get through the certification process, but that's our goal. It's quite aggressive.
So I'm gonna get on this ride share. I'm gonna give you 5 stars.
Yeah.
And a $5 tip for the ride.
Oh, $5. Yeah. Okay. Thank you, sir.
Thank you, RJ.
Okay. Thank you.
Thank you so much for taking the time.
All right.
I hope you enjoyed this interview.
Cheers.
One of one test pilots that can actually fly one of these. Thank you, RJ.
Yeah. Thank you, George.
Like, share, and subscribe, and we'll see you for the next one.
All right.